Sharing a neutral on 120/208 volt 3-phase GFI circuits is acceptable, provided the neutral is split before connecting to the GFI. This is similar to the principle applied in 120/240 volt circuits. However, with 120/208 volt 3-phase systems, there is a crucial factor to consider. The neutral conductor in a 120/208 volt 3-phase system can potentially carry a higher current than any of the individual phase conductors. This occurs because the neutral serves as the return path for any unbalanced current among the three phases. In a balanced three-phase system, the currents in each phase are equal and 120 degrees apart, resulting in a minimal neutral current. However, in real-world scenarios, loads are rarely perfectly balanced. Uneven loading across the three phases causes current to flow in the neutral conductor to compensate for the imbalance. Therefore, it's essential to carefully calculate the potential neutral current and select a conductor size that can safely handle it. To illustrate, let's consider a scenario where each phase conductor is carrying 10 amps. It might seem logical to assume that the neutral conductor would also need to handle only 10 amps. However, due to the phase relationship with the currents in a three-phase system, the neutral current is the vector sum of the three-phase currents. The vector sum of three 10-amp currents with 120-degree phase shifts is not simply 30 amps, but rather the square root of 3, or approximately 1.732 times the individual phase current when the loads are equal to each other. In this case, it is roughly 17.3 amps. So, even with each phase carrying only 10 amps, the neutral conductor may need to be sized to handle at least 20 amps to provide an adequate safety margin and account for potential future load increases or imbalances. The National Electrical Code, or NEC, provides guidelines for calculating neutral conductor size in three-phase systems. These guidelines take into account the type of loads served, the presence of nonlinear loads that generate harmonic currents, and other factors that can affect neutral current. Nonlinear loads, such as electronic devices with switching power supplies, can produce harmonic currents that significantly increase the neutral current. These harmonic currents are multiples of the fundamental frequency of the AC power, which is typically 60 Hz in the United States. The third harmonic, which is 180 Hz, is particularly problematic because it adds directly in the neutral conductor in a three-phase system. This means that the neutral current can be significantly higher than what would be expected based on the fundamental frequency currents alone. When nonlinear loads are present, it may be necessary to increase the neutral conductor size by as much as 200% or more to accommodate the harmonic currents. The NEC provides specific guidance on how to calculate neutral conductor size in these situations. Some general rules to follow for ensuring proper neutral sizing in 120/208 volt three-phase systems include: firstly, accurately determine the load on each phase, taking into account both linear and nonlinear loads. Secondly, calculate the potential neutral current based on the phase currents in the presence of any harmonic currents. Thirdly, select a neutral conductor size that is large enough to handle the calculated neutral current with an appropriate safety margin. Fourthly, consult the NEC for specific requirements and guidelines on neutral conductor sizing. Fifthly, consider using a separate neutral conductor for each circuit to minimize the risk of overloading the neutral. Sixthly, when using shared neutrals, ensure that the neutral is properly sized and that all connections are tight and secure. Seventhly, use appropriately rated GFI receptacles that are designed for use in three-phase systems. Eighthly, regularly inspect the electrical system to identify and address any potential problems, such as loose connections or overloaded circuits. By carefully considering these factors and following the NEC guidelines, it is possible to safely and effectively share neutrals on 120/208 volt three-phase GFI circuits. Always consult with a qualified electrician if you have any questions or concerns about electrical wiring or safety. When dealing with electrical systems, remember that safety is paramount. Always energize circuits before working on them, and follow all applicable safety precautions. Electrical work should only be performed by qualified individuals who are trained and experienced in electrical wiring and safety. If you are not qualified to perform electrical work, it is best to hire a licensed electrician to do the job. Working with electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others from harm. In summary, sharing a neutral on 120/208 volt 3-phase GFI circuits is generally permissible if the neutral is split before the GFI. However, the increased potential for high neutral currents necessitates careful consideration of conductor sizing and adherence to NEC guidelines. Prioritize safety and consult with qualified professionals when working with electrical systems. Always ensure that the neutral conductor is adequately sized to handle the unbalanced load and any harmonic currents that may be present. This will help to prevent overheating, voltage drop, and other problems that can compromise the safety and reliability of the electrical system. When in doubt, it is always best to err on the side of caution and use a larger neutral conductor than what is strictly required by the NEC. This will provide an additional safety margin and help to ensure the long-term performance of the electrical system. Also, remember to properly label all circuits and conductors to prevent confusion and ensure that maintenance and repairs can be performed safely and efficiently. This includes labeling the neutral conductor with the appropriate voltage and phase information. By following these guidelines and best practices, you can help to ensure the safe and reliable operation of 120/208 volt 3-phase electrical systems. If you're not certain about any step, please consult a certified electrician to check your work.